So, before we get into lecture, do you guys have any questions about anything? Okay, then we will pick up from where we left off. So last time, right, we'd gotten to the point where we'd finished writing a function that could make everything inside our string lowercase. And the important things to remember were using a reference in our type so that we modified the original. It's not going to be on Canvas. It's on the class Google Drive. So if you look, like as I edit it, it gets updated there. The important thing to use a reference on our type that we're accepting because we wanted to modify the original. And then also to make sure that we used a reference here when we went through each of the letters so that we actually would modify them in line 10. I'll comment these out so that we don't spend extra time doing stuff that we don't need to do. But these other ways are also valid ways of writing it as well. So the next thing that I want to do is just call the void lower. And then here we're just going to accept this, not void lower. We're going to return a string. So we're going to make a copy of the original that was passed in, and we're going to return that. We're going to take a string, we're going to make it lowercase, and we're going to get back the version. We're going to get back a version of the string in lowercase, but we won't modify the original. So because we're not planning on modifying the original, we're going to accept a const reference. We also could accept just a string or a const string here without the reference. But the downside of doing so would be that we'd have to copy over the entire contents of the string, which could be very expensive if the string is quite long. If we don't, since we don't want to copy over all the individual characters, we are just going to accept a reference to that object instead. So what we can do here is fairly simple. We can make a new string called maybe lowered, and it will start as having the same contents as the original string. And then what we could do is we could just say lower, but in place lowered, and then we could return lowered. So what we do is we create a copy of the original right here on line 27. We make that copy lowercase, and then we return that lowercase version. Any questions? So we're just reusing some of our code. Now, my question to you would be, what would happen if we had done this? Again, assuming the types matched up and we had put a reference here. Would this be okay? And we had made this guy a reference. Yeah. So what we're doing before was correct. We want to return a new string. My question to you guys now is, if we had decided to return a string reference instead, would that be okay in this case? If so, why? Would it not be okay? If it wouldn't be okay, why? Yeah. Yeah, so there actually is something to reference to, right? We'd be returning a reference to lowered, but where is lowered created at? It's created in the function, right? So anything, any of your local variables or arguments, they're created on the stack. But these variables, they only last for how long? Like, how long is lowered going to last for? Until the end of the function, right? So if this function returns, what's going to happen to lowered after it returns? It's going to get deleted. So now we have a reference to something that's been deleted. And so what's going to happen to us? Well, we kind of get screwed over, right? Because we now have a reference to something that's been deleted, bad things would happen. So this would be a case where we do need to make sure that we return a brand spanking new string and not a reference to the one that's on the stack. Does that make sense? Any questions about what we just did? Why would it get deleted after the function ends? All local variables, which are arguments, or all local variables and arguments are deleted after that function completes, right? Just how it works. Yeah. So your question is, what's the point of putting it as const? There are two main reasons for making it be const. The first reason is we're not planning on changing it, right, in this function. So we should make it const so that we don't accidentally modify it, right? The other reasons for why we might want to make it const is since the user, whoever is using our function, knows that they're getting that this function receives a const reference, they know we won't be changing their string, right? If they just took in a string reference, you may or may not change my string, and I have no idea if you're going to. The third reason, which you'll probably see a lot later on, is that by making a const reference, it's usable in more contexts. Sometimes you only have const objects, right? Like I have a constant string. If I had a constant string, I could pass it to this function lower, and it would be able to lower it because I can accept a constant reference. But I wouldn't be able to call lower in place on that constant string because it's constant, right? And this string reference would allow me to be able to change the string potentially. But then we copied it anyway. So it might be slightly more efficient in this problem not to do the reference here and just receive a copy on the stack. And so now we're getting a copy. And so we might just now say lowered in place string, and then we could return string. Const is a modifier to a type. And if you apply const to a type, it means you cannot modify that variable. The question is, can const be removed? Yes, it can be, but we're not going to talk about that until maybe the very end of the quarter, because removing const is probably not something you should be doing. But it is possible. But you want to do so very, very carefully. Any other questions? Okay, yeah. So doing it the other way around, there's no benefit necessarily. The only time it would have had a benefit is if we had decided to copy string again. If we were still trying to copy string one more time, that would be 2 copies of string, right? But here I'm only still creating 1 copy. This method is probably actually going to be maybe a little bit faster depending on compiler optimizations. So we accept a string, which we actually get a copy of the string that we're given. We make it lowercase. Again, we make the copy lowercase, and then we return the copy. So again, but it gets returned, so it won't be deleted. And we're not returning a reference, we're returning the actual object itself. So the object itself will be copied out. So again, probably seeing this in practice might help. So since we want to be able to lower a string, we want to be able to use a string, so we need to include string here. And since we want to be able to lower a string, that's inside more string functions. And again, we use the quotation marks for including our files, the triangular brackets for the standard library stuff. So we might say something like enter a string. We might have std : string input. And we might have another one that's called quiet. Get rid of this. So then we might cin into input, and then std cout your, oops. No, it would still autocomplete to be either one, whether it was the triangular brackets or the quotation marks. And so now if we go ahead and we run our code, okay, there we finally go. So we might enter in something like shout 58, and then our quiet string is shout 58. So again, anytime you want to make use of any of your functions that are, or make use of any functions that are declared in another header file, you have to include that header file in that file. So since I wanted to use lower, I had to include it over here. Any questions? Yes. So the question is, when would you want to have multiple CPP and header files? When your project gets big is generally the reason, and a lot of it's like organizational issues. We're able to keep related functions together in the same file. Notice that all my char functions are in this file, right? They're all grouped together very nicely. And so if I only want to use these character functions, I can include them. Or if I want to use any of my string functions, which we currently only have 2 right now, we're going to write one more in a minute, we just have to include this file and we're good to go. The char functions are referenced inside morestringfunctions.cpp. So we included it over here because we needed the 2 lower in that file. Any other questions? Yes. Can you delete the element that you're at? Yeah. So the question is, can you delete an element the iterator is at? Yes, you can. The method that you would use is erase. But then after you erase that element, all of your iterators to that object are no longer valid. So you'd have to get a new iterator again. I think it's technically, the truth is, all iterators that are past the point that you deleted are no longer valid. And including the one that you're at. You would then, but any iterator that happened to be before the object is still good, but don't quote me on this. I would just say, like, if you delete or insert something into an object, consider any iterators you have to that object invalid, and you need to get new ones. So the next function that I want to write is strip. And if you remember, strip removes characters from the left and from the right, right? And you get to specify that sequence of characters to remove. You guys have used strip in Python before? So by default, what are the characters that we want to strip? White space. What characters does white space consist of? Tabs and space and new lines, right? So we might have our function void strip in place, and we might have our std string, reference string, because we're planning on modifying it again. And then we might have a const std : string reference equals string reference characters to remove equals tab new line space. right? Because by default, we want the characters that we remove to be tabs, new lines, and spaces, right? And so if the user doesn't specify which characters to remove, we're going to remove white space. Does that make sense? Are there any questions syntactically about what's going on here? Okay. So remember, the optional arguments, they only go in the declaration if you have a declaration and a definition. So they're not going to show up here. So what do we need to do to our string in order to strip it? Well, we could break this down into two things, right? We need to strip the front, right? And we need to strip the back. Agreed? So in Python, there are functions called lstrip, and lstrip removes characters from the front, and rstrip removes characters from the back. So we might say lstrip, well, we still want to lstrip the string, and we still want to give it the characters to remove. And then we rstrip. Woo, we're done. Right? Except now we've just created two new problems for ourselves. Stripping from the left and stripping from the right. But wouldn't you agree that both of these problems are slightly easier to solve than the original one? Probably. So that's what you want to do when you solve problems. Break them down into smaller problems. Take your problem at big steps, state what you want to do, strip the left, strip the right, make functions to make that happen. Oops, I actually want to call this lstrip in place, and this one place. Because I'm doing it in place, and so we'll create ones that return copies of the modified string, which will pretty much function like we did a lower and lower in place, where we'll make a copy of the thing and then do the modification on the copy. And this should be called a strip in place, not string in place. So we'll create two new functions. Lstrip in place, and its arguments are going to be the exact same. And we're also going to do rstrip in place, and its arguments are going to be the exact same. Okay, guys, how do we do an lstrip? Yeah. The characters will be the arguments, because with strip, you can specify a different set of characters to remove. So by default, we've specified them to be tab spaces and new lines. Or maybe you want to remove all the A's from the beginning of your string, or all the A's, C's, and X's. Right? The user could specify a different set of characters to remove instead. If the user decides to pass in as tab the characters to so let's put it this way. If the user passes in anything to this parameter, we'll use what they said. So if they said only tabs, we'll strip only tabs. If the user doesn't say what characters they want to remove, we will remove white space instead. Right? That's how the default parameters work. If you don't provide it, we'll do what you see here on the screen. Tabs, new lines, and spaces. If you tell me to do something different, I'll do what you told me to do. And you guys are all familiar with the syntax for writing tabs, new lines, /t/n? So how do we strip in place? Again, we want to do the left strip. So we want to remove the characters from the beginning that happen to match any one of these. Yeah. So we want to go through each of the characters in our string, and we what? So eventually what we're going to need to do is to erase the characters from the string, and there is an erase method, but erase takes an iterator. So our for loop that we're going to do here has to be an iterator-based for loop. to make that happen. But again, if we ignore that from the beginning, we want to go through each one of our characters until we find what? A character that's not in characters to remove, right? And then once we find that character, right, we should delete everything and up into that spot. Agreed? So what we could do over here is for auto iter is equal to a string dot begin. Iter doesn't equal string dot end. How do we go to the next element? Plus plus iter. So if, right, we want to see if like star iter appears inside characters to remove. So we might say, you know, if contains chars to remove, right? So if characters to remove contains star iter, what should we do? Or if it doesn't contain it, right? We should so we found a character, right, that's not one of the characters that we want to remove, right? We don't want to skip it, right? So if I want to remove like all the A's and I see like, oh, it's A, C. Do I want to keep going? No, I should just stop right there and I should get out of my for loop, right? So what statement would you use to get out of your for loop? Break. And break still works here just like it does in Python, right? Continue also works the exact same way. I also need to do this to make this work. So all the fields over here in the for loop can be left empty except for the condition. The condition has to contain something. And the reason why I'm moving iterator out of here is because I'm going to need it later on. So there's a method on strings called erase. Oops. And so for erase, we give it a pair of iterators. The iterator that we want to start erasing at, and up into, but not including the iterator that we want to stop erasing characters from. So where do we want to start removing characters from? From the beginning, right? So string dot begin. And we want to stop where? Not string dot iterator, but just iter, right? And this will allow us to delete everything up to, but not including where iterator is at, because iterator is pointing to the first character that we don't want to delete. The reason why I had to move iterator out of here is because if we had defined it inside the for loop, it would only exist for the for loop, and I wouldn't be able to refer to it on line 43. So I have to define it a little bit before on line 37, so that's not inside the scope. Its definition is not in the scope of the for loop. Yeah. It's not. It might move. Right? At the beginning, yes, it starts as begin. So like the very first character was something that we didn't want to delete, we would not delete anything. Right? But if the first character was something that we did want to delete, we'd keep advancing past the first thing. Well, it's defined outside the for loop, but it's used inside the for loop.
So it's like a number.
Yeah. So the question is, what happens if tab is in the middle? Just like what Python would do, we would not remove it. So we only remove the beginning and well, for lstrip, we only remove the beginning set of characters that starts with it. We don't remove any interior ones. Any other questions? Yes. Correct, right? Because iter has been changed, right? It's been plus plus to be moved beyond. So yes, it has been modified. It's now pointing probably somewhere past the beginning, but depending on the string, it could still be at the beginning. Okay, you guys seem like you have questions, so let's ask them to me. So what's up? Yeah. So again, the star before the iterator is to get the value that the iterator is at. So if I think about the iterator itself is at a position, right? And then if I want the actual value at that position, I have to put the star in front of the iterator. Anything else? Yeah. This semicolon? And again, it separates the three fields. So since I don't have anything in this field, I would still need the semicolon there. Because if I didn't have the semicolon here, it would think this expression is the initializer. So I'm still going to need I'll still need both semicolons, but there might not need to be anything in that field. Just blank right now. Yeah. I mean, if there's nothing there, it does nothing. This, line 37, it happens before the for loop, so it has to happen before the for loop. Anything else? Yes. No, we're doing this code because it's going to be useful in your assignment. So yes, you're more than welcome to use any code that we do in class on your assignment. And you will probably find this to be very useful. Any other questions? Yes. So if I put this inside the for loop, oops, there's an extra semicolon there. So notice if I put this inside the for loop, it's like, hey, there's the use of an undeclared identifier iterator. I don't know what iterator is more or less what it's saying. Because if you declare a variable inside the for loop, it only lasts up until this curly bracket. So since we're past that curly bracket, that variable no longer exists. So in order for that variable to exist past the for loop, I have to declare it outside the for loop. Now it lasts till the end of this curly bracket. So in general, wherever you define a curly bracket, define a variable, it lasts from that line of code to the end of the curly bracket that it's enclosed inside of. So now it lasts from line 38 to line 45. Any other questions? Okay, so we've come up with a new problem. We have to figure out if a string contains another string, or not a string, if a value appears inside some string. So what we might define over here is bool contains, and we want to see we have a const std : string reference string. Yeah, but we're going to do contains first. And because right strip is more or less the same, except we start from the right. But I want to finish contains first, and then we'll get over to our strip. So we take in a string reference. This is the thing that we want to search. And then we take in a char letter. So we want to see if this string contains this letter. We could rearrange the variables later on based on what we needed to do. So one method that you might find helpful, and there's a really useful library of methods contained inside of the algorithm header file. And so what algorithm can see is there's some functions that will allow you to check to see if hey, are all of the elements inside this container, do they meet some condition? Or do any of them contain this condition? The one that we're going to use right now is find. And what find ends up doing is it searches between this pairs of iterators, which I'll zoom in so you can see. It searches between this pair of iterators, first and last, to see if it contains this value. If it does contain the value, it will give you an iterator to the first occurrence of that value. If it doesn't contain a value, it will give you last back. Does that make sense? So there's a little example down here. So the person made an array of integers, and they asked it to check between the beginning and the end for the value 30, which it gave it back the position over here. It's being done with pointers instead of iterators to this position where 30 is at. Used in our code, it's going to be fairly similar, but we're going to need to include algorithm to be able to use it. Also, when you're doing your includes, all of your standard includes should be done at the beginning. And then all of your files should be done afterwards. String here to be extra safe. So what I can do is I can do std : find, and I want to start searching from string.cBegin, string.cEnd, and I want to see if it contains the letter. Then I want to check to see if this thing, if it's going to contain it, how will we know if it contains it? Right? It gives us back an iterator. It'll be to the position that of the first occurrence of that letter, or it will be to this value if it's not there. So if I find it, what do we know about the iterator that gets returned? Yeah. Or if it's not equal to the end, right? So we attempt to find somewhere between, starting at where string begins, up to but not including the end. We want to see if we find letter. If we do find letter, it's not going to be equal to the end of the string. We'll find it somewhere before that. If we wanted to, we also could have written the for loop ourselves. Let's say like, for each character in the string, if the character doesn't equal, or if the current character doesn't equal letter, it return true, right? That would look something like for const auto reference a curchar in string if curchar is equal to letter, return true. Return false. Right? Either is equivalent. I just don't like writing much code. So I would do it the first way. Yeah. So the difference between cBegin and begin is begin can return a non-const iterator, while cBegin always returns a const iterator. The const iterator, you can only read the value that's there. You can't modify it. With a non-const iterator, you could also change the value that you're currently at. Any other questions here? Yeah. In what case do I add the reference symbol? Yeah. So there are two reasons why we might use reference. So normally you'll see me just accept a function will either accept a reference or it'll accept a const reference. If I'm only planning on reading the variable, I'm probably going to accept a const reference to avoid having to copy the object to save time doing that. Does that make sense? So if you have an object that's not one of the basic types, char, int, double, and you only plan on reading the value, have your function accept a const reference to it. It'll be a lot faster to pass it to the function and reduce your program's runtime. The other time I might pass just a regular reference to a function is if I want to modify the thing that I'm given. Right? If I want to modify the thing that I'm given, my function must accept a reference. Right? So back here when we were doing something like lower in place, I want to modify the string that I was given. So I must accept a reference, right? Because if I don't have a reference here, I get a copy. And therefore, I would only change the copy, which doesn't do anything to the original, which makes it look like this code has no effect. Does that make sense? Any other questions? Why do I make what?
What is void?
Void means my function does not return any values. It doesn't return anything. So I'm just modifying what I was given. I don't plan on returning anything. Yeah. So I understand what your question is. So remember, C-end is not the last character in the string. C-end is always one beyond the last thing, right? So if we had like the string hello, it'd be like right after the O and hello.
Like length.
Or not length plus 1, but length, because we use zero-based indexing.
Oh, yeah.
But again, like the one after the last thing is kind of like in quotation marks, because it's not always going to be like the last thing plus 1, because not all iterators support like plus 1. But it's not in bounds. Don't dereference. Do not dereference end. So correct. You could just have a copy, so auto would work. But generally, you're going to find that if I'm just iterating through any container, regardless of what its type is, and I'm not planning on modifying the contents of it, I will have a const auto reference because I just want to read it. Yeah, it's trying to save space, right? Because and not only save space, but also save time, because copying things takes time, right?
Something you personally like it?
I do this because it's like a standard convention, but it's also going to have performance benefits in your code as well. If I have to do less copying in my code, right, it's going to take less time to run it. Yeah. The one on lines 51 to 55, that would be like the element-based for loop, because, you know, for const auto reference in the string. If I was doing the iterator-based for loop, you're going to see begin and end show up. Yes.
Yeah.
Mm-hmm.
Why are we like friends like that? If you like, it has the value.
Correct. It's not going to change the value, which is why I have const, because I'm not planning on changing it. And it's a reference so that I avoid having to copy the object, which takes time.
That's what AB. Not AB, but A. And I want to check if there. Where did it get stuck at 8? But
So correct. If we wanted to like count the number of occurrences of a particular character in the string, this is not going to work, right? But all I care about in this particular function is if it contains it. Right? Now, if I did want to count the number of occurrences of that character, I could do it. Remember, find is going to give me back an iterator to where it found the element at. So what I could do after I found it is I could start at the iterator I got back +1 until it reached end. And then I could count how many times that happened.
So wouldn't it be like that? Car would be like, even if you're not talking about, but if it's like, it's 8.
Uh-huh.
So would it like, because it's auto, would it be like it would be reference to this?
No, it will not always be referenced to the string. So this creates essentially like a new reference every time it goes through. So the first time it would be at A, next time at B, next time at C. The const auto just means I cannot change that A to be a J or that B to be an X. I cannot change the elements inside the string. I can just read them. So let's get to right stripping then. I'll move this up. So how could we do a right strip? Yes. So we want to begin at the end, right, and then work our way backwards. So we probably want to use a reverse iterator. So here we'll copy and most of the code, but there's going to be like one small difference, unfortunately. So we want to start at const reverse begin, and we want to go to const reversed end, right? Now, if the characters match, we want to, if we find a character that's not one of the ones we want to erase, we're going to stop. Now, with erase, it only takes forward iterators. It can't use reverse iterators. But your reverse iterators have a method called, I believe it's base. And base, will give you a forward iterator to essentially the same spot. But now I want to start at iterator.base, and I want to go up to, but not including, string.cend. This one might need to be a, oh, oops, not here. No, it's not outside the curly brackets. I might just need to change this to be, there we go, that worked. For some reason, it didn't like having the const reverse iterator, for whatever reason. Oh, we couldn't use the const reverse iterator because we're planning on actually modifying the elements. So that makes sense. So again, we just start our way from the end and work our way towards the beginning, the reverse end. But the erase method has to take in two forward iterators. So we want to start at the iterator.base, which is the forward iterator to the same position that the reverse iterator is at. And we want to go to the end. Any questions here?
The end here be
No, this is end, not our end. So end is the far right of the string. Wherever iterator is at. Well, I mean, so iterator starts at the reverse beginning, or the end of the string. Okay, we're cool here? Yeah? So the question is, should it be minus minus over here? No, because when a reverse iterator goes forward, it goes backwards through the string. That might seem confusing because the reverse iterator goes through the string in reverse, so advancing to the next character actually moves you towards the beginning. Anything else? String.rend is one before the beginning. Yes? I know it's a reverse iterator because it starts with R. It's a function defined on strings. So strings have an R begin and an R end, a reverse beginning and reverse end. These give you reverse iterators. Okay, anything else? Yeah. Yeah, so these iterators specify the range of elements to erase. Yes. Only if the first character that appeared at the end of the string was one that we did not want to erase. Right? You know, if this is our string, and the characters that we're trying to remove are B's and J's or whatever. I don't know. Notice that S doesn't start with any of these, so we wouldn't do it. Right? So we would just stay at the end and we wouldn't erase anything from the right. But if we add an S in here, we're going to start from the right and erase this one, then erase this one. Oh, A is not a B, J, K, U, or S, so we're going to stop here at A and erase everything that comes after it. These two S's.
Oh, so that's what the end.
Yeah, the end is the far right, which is probably for you on this side. Because we're doing our strip. We're stripped from the reverse, stripped from the end, stripped from the right. On the string.
And you create a new end.
Yeah, we wind up creating a new end after we erase the characters. Because after we erase it, it's just going to be high claw or whatever. So let's try this out. Let's say we accept in quiet. And then we want to do strip in place from quiet. And let's assume that the strings we want to remove are A's, B's, and C's. Cool. So let's try starting this up. So maybe our string is AABBC, AAB, DD, EFG, AABBBAC, something, and then it goes to be GH, BBBBAACCC, BA. I don't know. Right? So after we strip this, we'd expect all of this up until here to be deleted, right? From the left. Right? Because those are a sequence of A's, B's, and C's. From the right, we'd expect to delete everything up until here. Oh, it did it. Right? And if you're curious, how is this working? Right? How is this happening? Throw your code into the debugger. So we'll do lstrip just to see it happening. And we'll hit the debug button. And we'll go with a slightly less crazy string so it doesn't take so long. So AABA, DG, BBAC. So now our code has paused on this line right here. And we step into it. And so we might also be interested in seeing what's the value at star iter. So I'm going to add a new watch, star iter. And that caused things to crash for whatever reason. So apparently it won't let me do start iter. Sometimes with these set of characters, it doesn't always work very well here in the debugger for displaying them. I'm wondering if I can do E star iter. Nope, that just kills everything for reasons I don't understand. But anyway, if we could see it, we would see that it would go through each one of these pieces of characters until it finally found one that didn't match. We would then leave, and since we've left, we'd then erase everything afterwards. We will continue to get into some more topics on Friday. We'll probably get into vectors and containers. Do some more examples. We'll probably do split. If you have questions, you're feeling confused, do please come to office hours. It'll give me more time to work with you to go through those concepts.
Professor?
Good.
Yes.